Solutions for the mock final exam for second semester Math 10. 12-page test, so bear with me. Here's page 1. First question. Find the equation of the axis symmetry and the vertex coordinates of the quadratic function below. Okay, so remember that there's an equation for the axis of symmetry, and on your note sheet you should have it. It's x equals negative b over 2a. So all you need to do is identify b, which is negative 4, and a, which is negative 2, right? Because ax squared plus bx plus c. So then you take those two values, negative 2 and negative 4, and you substitute into the equation. So you have x equals negative 4 over 2 times negative 2. Negative 4 is positive 4. 2 times negative 2 is negative 4. Result is negative 1. So when you write the equation of the axis of symmetry, you do need to write x equals negative 1. You can't just write negative 1. Okay? X equals negative 1 is the equation of the axis of symmetry because it is the equation of a vertical line. Okay. And what are the vertex coordinates? Well, the vertex coordinates can be found using the axis of symmetry, which gives you the x coordinate of the vertex. Okay, you just need the y coordinate. How do you find the y coordinate? Well, all you do is you substitute in x for x squared. You substitute in x equals negative 1, and that will give you the value of y that corresponds to negative 1. So I'm going to do that here. So I'm going to put negative 1 for x here, negative 1 for x here. And then that gives me negative 2 times negative 1 squared. Negative 1 squared is negative 1 times negative 1, which is positive 1. Okay? So negative 2 times positive 1 is negative 2. Negative 4 times negative 1 is positive 4 plus 6. So I have negative 2 plus 4 plus 6, which gives me 8. So my y coordinate for the vertex is 8. So the vertex is going to be negative 1, 8. And the axis of symmetry is x equals negative 1. Okay. Does the graph function form a parabola which opens up or down? Which part of the function tells you that? Well, the part of the function that tells you that is the a value. The a value is negative 2, right? So, opens down. Okay, which kind of means it looks like that. All right. Number 2. Find the discriminant of the quadratic function below. Okay, it's the same quadratic function. This time they're asking for the discriminant. So the discriminant you should have in your formula sheet that the discriminant is equal to b squared minus 4ac. So here we can identify a, which is negative 2, b, which is negative 4, and c, which is 6. And b squared minus 4ac would be negative 4 squared, which would be 16, minus 4 times negative 2 times positive 6. So that would be 16 plus 48. 16 plus 48 is 64. Okay. So our discriminant is positive 64. Interpret what the value of the discriminant says about the appearance of the graph of the function. Okay, on your formula sheet, you should say that when the discriminant is positive, that means you have 2 roots. And if the discriminant is negative, you have 0 roots. And when the discriminant is 0, then you have exactly 1 root. Okay? So, since we have a positive discriminant, that says that we have 2 roots. And what does it say about the appearance of the graph of the function? 2 roots means 2 x-intercepts. Okay. Moving on. Find the zeros of the function by factoring or other method. So the zeros of the function, let's answer this question here. What are other names for the zeros of a quadratic function? Okay, instead of zeros, you could say x-intercepts, because it's the same thing. You could also say roots. Maybe I'll think of some other name, but that's all I can think of for now. So how do you find roots or x-intercepts or zeros? Well, normally, if you can factor the function, you would use factoring. And when you have this, the first step to the factoring would be to factor out the a value, -2, and you factor it out of every single number. So factoring a -2 out of -4 leaves 2x. Factoring a -2 out of 6 leaves a -3. And then I'm going to try to factor x squared plus 2x minus 3 into two binomials, and that would be x plus 3x minus 1. Does that work? Positive 3 times -1 gives me -3. That's perfect. And then the inside and the outside, 3x times 3x plus -1x give me 2x, which is the middle value. Perfect, it worked. So the zero values are going to be x equals -3, because if I put -3 in, that would make this binomial 0, and the whole thing multiplied together would be 0. And if I put a positive 1 here, then that would also make the whole thing 0. So the two zeros are x equals -3 and x equals +1, because those are the values. If I put it into this factored form, it would immediately make the whole thing 0. Okay? And another way you might do it would be using the quadratic formula, and definitely put the quadratic formula in your note sheet. Okay, so if you use the quadratic formula and substitute in a equals -2, b equals -4, and c equals 6, you will get two possibilities. One is x equals -3, and the other is x equals +1. Okay, so let's move on. What is another symbol you could use in the equation instead of f of x? Okay, and remember that instead of f of x, you could just have y. The reason why we use f of x is it makes it easier to see that it's a function based on x. Okay, when you put x into the function, it gives you a value for y. And the other thing is it kind of names the function. So if you're working with multiple functions and you have one function called f of x, you can call it f of x, and then you don't get it mixed up with the other functions that are also yield values of y. Okay, so the answer to that is y. What is the y-intercept of the quadratic function f of x? Okay, so there's two ways to do this. One is you say, okay, if I want the y-intercept, that would be a coordinate pair where the x value is 0 and the y value is something else. Well, if the x value is 0, I can substitute in x equals 0 for all the x values. And you can see that that makes this value 0, it makes this value 0, and just leaves +6. So actually, when you see a polynomial in this form where you have x variable, and then you have the constant term at the end, the constant term also happens to be the y-intercept, because whenever you put x equals 0 into this equation, it ends up making all the terms equal to 0 except for the last term. So that's why the last term is usually the x-intercept for a polynomial. Okay? So in this case, I'm going to say the y-intercept is 6. You could also put it in coordinate form like that. Okay. What information from number 1, number 2, and number 3 can you use to graph the function f of x? Now, do you see that this is the same f of x as before? And remember that we have the vertex from before. The vertex from before is -1, 8. And another thing that we know, we of course know that the axis of symmetry is x equals -1, but we already kind of have that taken into account by the -1 here. We also know that the y-intercept is 6. We just got that. Okay, and let's see if there's anything else. We do know that the graph has two x-intercepts, and we know that it opens down. Okay, so we're going to write that. Opens down, and two x-intercepts. Okay, Oh, and the x-intercepts, we also know the x-intercepts are at +1 and -3. Okay, so we know quite a bit. Last thing. Find the directrix equation and focus coordinates for the quadratic function. So remember, to find the directrix equation and focus coordinates, first you need to take the vertex, and then you need to look at a distance of 1/4a away from the vertex to find the directrix and the focus coordinates. So we call that distance p. So it would be 1/4a. A happens to be -2, right? Now, instead of -2, you could just put +2 because it's a distance. It doesn't matter if it's negative. So it turns out that the distance we're looking at is 1/8. That's pretty small. Okay, so let's mark some of these important points on the graph here. First of all, -1, 8, the most important point, is the vertex. So I'm going to mark that here. Next thing, we know that we have x-intercepts at 1 and -3. Another thing is we know that the y-intercept is at 6. And another thing we know is that it opens down, but that's pretty obvious. Now that we mark these points here, we can see that it does indeed open down, right? Okay. All right, kind of like that. Okay. This is actually not a good drawing because if I know that 0,6 is a point on the parabola, I also know that the opposite point, which in this case would be -2,6, is also on the parabola. So I'm going to redraw this so that it actually goes through that point. Okay? All right, that looks pretty good. Next thing we're going to do is we're going to mark the directrix and the focus. And remember, the directrix and the focus kind of sit close to the vertex on either side of the vertex. And basically, they're separated by the vertex by a very small distance. And in this case, the small distance happens to be p = 1/8. Okay? So, for example, if I was to say, how far is it from here to here? I would say that the distance is p = 1/8. Okay? And I know that my vertex coordinate is -1, 8, right? And so that means that to get to the directrix, I would add 1/8 to 8. And so 8 plus 1/8 happens to be 64/8 plus 1/8, which would be 65/8. Okay, so this directrix here, the equation is y = 65/8, which is 8 plus 1/8. Okay, and since it's a horizontal line, the form of the line for the directrix is y = blah, blah, blah. In this case, it's 65/8 because I took the 8 and I added 1/8, right? Now, to find the focus coordinates, I take the vertex coordinates, and I just take the y value, and I subtract 1/8, which would give me 64/8 minus 1/8, which would be 63/8. Oops. And the x value, of course, would be -1, comma, blah, blah, blah. Okay? So I just made the focus coordinates, and I have the directrix equation of the line, and I have the vertex coordinates. Okay? So I think I'm done, right? All right. And so that was page 1 and 2.